Here we're going to talk about how to scale monitoring systems. So I would like to understand how many of you run Kubernetes or your applications in Kubernetes or, okay, so that's why you're here, I guess. Then I guess you know Prometheus, right? And you use maybe also Elasticsearch, or you know about it, or you used it in the past, this kind of. So what about VictoriaMetrics ecosystem? Do you know it? How many of you use it in production? Okay, good. Then it's good because I'm going to tell you, because when I was preparing this talk, I was thinking, how can I tell all our ecosystem or our products without being super boring, you know, like maybe a commercial talk. And then what I decided is to tell you my own story, because this is actually how I learned about this product, these projects, they are a lot. And I think maybe you can relate. And if you are not using VictoriaMetrics projects, maybe it will help you to, or it will give you some ideas. Let's meet. My name is Jose. I work right now at VictoriaMetrics, running a wonderful team that is working on VictoriaMetrics Cloud, which I will just mention a bit later. I also collaborate in Madrid, where I am from, in the university, teaching physics for veterinary students. That's why I added some kittens here and there in the talk. And yeah, I've been also, apart from that, from my background in research or whatever, I was also part of productizing these wonderful observability open source projects at Red Hat, in this case, Jaeger or Grafana Tempo, OpenTelemetry Collector, Kepler. So I've been talking with many customers and many people having these problems, the same that I did. Apart from that, I work in product space, but I really miss programming. So from time to time, I try to do stuff in my mother tongue, which is C++. And yeah, I also miss a bit playing Metal, which I did for many years. And when I can, I do sim racing. Let's talk about those things later, if you will. That would be super fun. So let's start talking about the good old days, what I believe everybody that have jumped into microservice always think about, right? I joined this telecommunications company with backend engineer, as a backend engineer, right? And we were happy because we were like many teams working on this monorepo, and we were ingesting thousands of requests per second. It needed to be super fast. That's why it's C++. And we needed to like be super efficient and always like don't fail, right? But everything fails. That's the first rule of programming, right? When something failed, what we did, someone took us into this war room and I started to say, hey, this is failing, check it. And what we did was take a look at the logs. We had thousands of logs in different shapes and levels, you know, like debug level or warning level or error level. And we were, at the end, you know, you could trace with some thread ID because it was a monolith. You could check and say, wow, okay, there was a problem accessing the database because someone didn't really program well because they did this null pointer, whatever, and then we saved the day and everybody loved us and we were super happy. Okay. Then someone started to read, which is awesome, but sometimes, you know, with great power comes great responsibility, and understood or learned this thing called microservices. And they promised the moon, you know, like, hey, it scales, it's reliable, fast tech adoption, like it's flexible. I really need to read them because a lot of things were promised, right? This is a huge list of things. And actually, I took this list from, you know, Atlassian, right? Jira. We all love Jira, right? And also, of course, agility, right? Like dogs, I guess. And in the end, you know, happier teams. Your teams are going to be happier. And this is for you can check, and that's written there. Let's see if we were happy or not. So I was taken into this pioneering team in which we were going to write the future, right? Like, hey, learn about Docker, learn about Kubernetes and stuff. And we were doing this thing called microservice. So we were doing our small code that talked to a database, and we were needed to check some APIs or write some APIs to talk with others. But then we needed to learn, because we didn't know what on earth was there. So we started this jargon, right? Like, okay, kubectl get pods. It's not working because I didn't check all the namespaces. I don't know what's going on. What is a service? What is a stateful set? What is a deployment? What is a daemon set? What is a job? So there's a lot of jargon now into my backpack that I need to carry. I don't need to only know about C++. Now I need to know about all these things. And at the end of the day, you know what I would do? kubectl logs, and let's check what on earth is going on, right? And then I get something like this. But you know, as Alexander said earlier, we all love grep. So you end up grepping things and doing your own tooling and so forth, until you learn this tool. So I'm talking about observability. I really want to praise for this project. I'm sorry, nobody mentions that, and I really want to mention that. With this project, what I can do is I can really check what's going on in my cluster. In this case, I have a real small, like Minikube thing, kind of thing, and I can check, I have these systems by namespaces, and I can check that I have here a Jaeger, I have my own container running, and I can check even the image. So my point is, that's what I call a good start in observability, because that helped us a lot. So check, maybe not for production, but it helped me a lot because I was working every day. Okay, so I was here, I was pretty happy. And then some folks were migrating code from past that was written in Java because they knew Java. Some new kids started learning Go because it was super new, and they were excited, and it was actually cool, a good alternative to C++ because it was fast. And then, I don't know, people use UIs for things, so JavaScript and stuff, and these things needed to communicate. And we did a fairly good job because, I didn't need to care about those pull requests for those other repos because I was working on my own microservices. So everybody was happy. Until we got into production, right? So now we have our infra running these things and all, like I already told you about this, and these things need to run. And when something failed, the first thing was, you cannot put. Then they put us again in the same room, but then I don't know about JavaScript, so I will not go there and discuss with these guys. They will blame the guys who are written these microservices in Go, and they say, you gave me a wrong answer. And then the Java guys will come, no, I'm senior, you did it wrong, right? So what ended happening, we were happy, but then the manager was not happy. And because the manager wasn't happy, we were not happy anymore. So that's why I called it the error. So what do you need to do? All of this just to advocate a bit for observability, right? Well, there is this flame of hope, right? Someone installed a Prometheus. And with this Prometheus, they installed a node exporter in the infra and CAdvisor and these kind of tools. With that, we learned this thing called Grafana, and we started checking some dashboards. And this seems super cool. Like, this is the future, like when you see in the movies, these people in these rooms that are like super modern and hackers and whatnot, right? And we could check, hey, cluster-wide, how much CPU I have left, the RAM, the disk. Are there any interlocks there? Like maybe the disk I/O is super high, and then I am having problems with that. I can go per container, per pod, per namespace, and start getting all these information and do investigations. So it was out of the box, and I didn't even need to touch my code. So that was like a great leap for humankind, right? All right. What we decided is, this is so cool. Let's put it in our microservices. Let's start creating our own metrics. Let's say, hey, I received a request. Put it there. I didn't even need to push it because Prometheus was coming to take it, right? So it was pretty neat, and we were super excited. But as with all software, there were always trade-offs, and I really like this movie because it's or the title, because it's a great representation of every choice you need to make in life, and more especially in software. So there were many good things, as I was saying. Great to start. Industry standard. We were we were working closed source, like super in a company, and we were using a CNCF project, so that was cool, right? There was a community there. We were excited. It gave us as a standard. I don't need to write it or to think about this standard of metrics. Someone is giving that to me. That's why the open source communities are so important, and it's so important that you guys are here and all of that. And I didn't need to provide it to install any agent, and it was telling me this target is unhealthy or this target is healthy. So it was already giving me a lot of information out of the box. However, it was bad for what I want to call ephemeral patterns. Like if I had a Kubernetes job, then, okay, I close, and who scraped my metrics? Nobody. If I need to implement graceful shutdown, then I am in trouble because I need to wait until I shut down my microservice. I need to wait until someone comes and all of these things. And also, Prometheus didn't have tenancy by then, right? And ugly things, right? Everything is super happy until you get into the details. For example, we didn't have any official C++ library to instrument. We needed to understand this new jargon. So it's good to have this new standard, but we need now to learn it. And what is a histogram? Where is these buckets? Where is all of that? You need to start learning, and then your backpack keeps on growing and growing. And this thing with cardinality, it can blow. Versioning labels, and my favorite ones. For scraping, I don't buy the scraping thing because or I don't like it so much because when I am debugging or implementing it for the first time, it was a mess to understand, like, hey, my metrics are not there. Why? I don't know. They are here. And then, is it connecting? Was the service? Was the problem? It was a bit of it was ugly. But nobody's perfect, right? No, it's always trade-offs, as I was saying, right? So it's okay. We were happy. We loved it. But things were getting real. And if you remember all of these things I was sharing, there was like this list, like this Kubernetes thing is going to solve all our problems. You know what was not here? Resource consumption was not here. And costs. But because humans, we think in this way, we see this list and say, oh, everything is good, right? But they forgot to tell us that. So people started screaming. And what happened in this case, if we're talking about observability, I'm here to talk about Prometheus and stuff, this thing was getting bigger and bigger. And what happens when this occurs is not only about noisy neighboring, it's also like, then it's useless. So now I have a database that I cannot use, and it's growing, and is interfering with my business logic operations. It's not responsive. The latency, it's a mess. Like, it takes a lot of time to read my dashboards. And what can I do? Why do I have this? And then people start getting nervous again and again, right? And this happened. And one day I was there, and as a programmer, you start seeing new or thinking, why these people are doing that? And then what I saw is this thing called Victoria here, Victoria there, and I was like, what is this? Why who did this? Why, right? And then I realized, and I was talking with this architect, and he told me, no, VictoriaMetrics, it's super efficient, and now it's not competing with our resources, and it's cool. And I started researching, and so up to now, of course, this is my story, and now I jump just to tell you what is VictoriaMetrics, right? So why would you change that? Well, actually, back then, there were some benchmarkings done by Alexander Valyalkin, the creator of this project, and I'm going to share that. But it's very important that no one size doesn't fit all, and always you need to do your own benchmarkings for your own use case, right? Maybe Prometheus, I told you, Prometheus made us happy. we were very happy. It helped us a lot. But for some cases, maybe it's not the best solution, right? So if we're talking about scaling, let's take a look at this benchmarking, just to put some numbers. In this case, node exporters that really produces real metrics produced by an infra were used, giving these numbers like nearly 300 data points per second for ingestion rate, nearly 3 million active time series, and yeah, this number, super big number that I like to put there to show off, hey, all of these samples, right? Billions, right? Okay, and when you compare how Prometheus does things with VictoriaMetrics, then you realize that storage, I can't really now, thinking back then, why these people did that. Of course, it was not my job. I was not looking at these numbers right now. When I was preparing this talk, I said, okay, this is quite a good increase in performance. As you can see, the disk utilization drops. Also about the write spikes, this is super important, like the I/O for write or read, because it will compete with your own resources. Then it's more performant in that way. If you think about CPU consumption in this particular benchmark, it was more or less the same. So if you don't have problems with CPU, then in this case, you will not be winning a lot. But for example, with memory usage, there was, in this particular benchmark, a huge reduction, right? So that's, and why is all of this important? As I was telling, you are using this database. We like to use numbers and to compare things, but at the end of the day, why is this important? It's not only about cost. It's also about when you reach these limits, you start to have crashes because out of memory, and then you start losing data, and things get messy, and your manager gets angry, and then you don't get your bonus, which is everything we want. And this was quite old, but actually I was checking to prepare this talk, like, okay, is there any recent benchmark? And then I found this from 1 month ago. It was like, yeah, like actually 1 month exactly. And which is like why this is the company owning Pinterest, this very big social network. And why they changed from Prometheus to VictoriaMetrics, and they were saying the same, so the numbers still apply, and the CPU usage, in this case, as I was saying, in this other benchmark, the CPU was not really a difference. Here, it made a lot of difference for this use case, and so forth. So, for example, and why is this important again? Like one query, like maybe you are forced to use queries that only take 15 minutes of data, because otherwise it will crash or it will take a lot of time. In this case, for this particular user, they could take data for hours instead of just minutes for these heavy queries, just to give one example. So, okay, we have better resource optimization, we have improved query performance, which is cool. What else do we have? I mean, it is, if you read on the internet, you will find out that VictoriaMetrics started as a fork of Prometheus. No, absolutely not. This is just me telling you, please don't use AI to write your articles, because things will be wrong. But it's not a fork, but you can use it as if it were. You can use it as drop-in replacement, as we did, right? I just woke up one day and I saw, okay, we have this Victoria service. What is that? It works just like that. So if you were scraping metrics, VictoriaMetrics can continue scraping metrics. If you were pushing metrics in Prometheus format, VictoriaMetrics ingest that, and also more that I will just say in a second. And you can continue using the queries. I will. There is a difference. That there was a question in the previous talk about query language for logs. In this case, there is MetricsQL that we could talk a lot about that. I'm actually not really an expert, because lately I'm not that much of a user, but that's why I put the asterisk. There are some subtle differences that are on purpose, between if you're using PromQL, but it should be very similar, and normally they work really, really well. What I like the most, integrations. You know, the CNCF landscape is huge, like a lot of projects. That's why we are here. And VictoriaMetrics, one thing this project does is trying to always be open to new standards and new ways to ingest data. If we have some user asking, hey, I need this one, this protocol, then there's a high chance that it may get implemented. So, for example, I don't know if you know Perses, for example. It integrates well with Perses, with Grafana, right? As I was telling, like you can just drop it and read the data. Perses is a new, let's say, open source project to visualize data. Actually, when I was at Red Hat, a lot of the team was involved implementing that part, and it's pretty cool. So it's I was very happy when I joined VictoriaMetrics and learned that this integration was part of the product as well. And yeah, one thing I want to mention as well is like there's this other project that is called OpenTelemetry that I have been also heavily involved in the last year or so. And this was very good for me, and I want to explain why. It has some problems because, for example, you can. It will give you a lot of resources, as they call, or attributes, and so the language starts growing, and the amount of data needed to be processed and to be collected grows. A single metric can be easier in a Prometheus format, but it has some advantages that I really want to advocate here. If that are, for example, in this case, the problem I had here, you don't have it because OpenTelemetry provides libraries for nearly all the languages. Also, you can use the same libraries and patterns for all the signals, meaning metrics, logs, and traces. So this means that I don't need to be looking for different libraries to include in my code and all of that. And is pushed based. And for that, then it helps to use, if you need to expose metrics in a Kubernetes job, then OpenTelemetry is a good choice. There's I was making the joke about buzzwords. This means that every project right now is also producing signals in OpenTelemetry format as well. So this interoperability is good to have. So I was very, very happy when I learned that there was this effort in the implementation in VictoriaMetrics to include OpenTelemetry to be native. More things to discuss are that if you want to migrate your metrics from Prometheus to VictoriaMetrics, what you can do is there are migrating tools that can help you to just take the snapshot and put it back into VictoriaMetrics. And now we are here to talk about the scalability, right? So let's continue about this. How can we scale? Well, the first thing is just to continue putting more and more fuel to your machine, to your train, right? So it will go faster, and that makes sense. That's what we all do, and that's called vertical scaling in Kubernetes jargon. Okay. We believe this can get you very, very far. So this is actually the recommended choice in case you don't need some things that I will mention later, and this will get you up to. It depends really on many factors, but you can think of this like 100 million active time series and 2 million samples per second. Is this too much? Is this too low? Well, 10 Kubernetes clusters with 15 nodes each with node exporters will give you a couple of million active time series. So maybe it's enough. And the same go, like if you have 500 node exporters, then it's 500,000 active time series. So one single instance, my point is, it can get you too far. Of course, if you start using your own metrics, these numbers grow easily and super fast. You can also have high availability mode in single. So if you're scaling, you can also consider this. You don't need to go into more complex stuff because it's easy to configure. But we know ourselves, and yeah, we want more. We will be creating more metrics. And even with VictoriaLogs, there was this meme about we need the cluster version, and people were complaining about that. So at the end of the day, it's given in the project, right? So if you want to scale in a horizontal way, which of course there are reasons for that, VictoriaMetrics clusters provide a distributed architecture which has three main components. One is the VM storage. This is internals, but if you end up needing it, you will need to understand it. And VM storage, as you can think, it stores the data. It also has VM insert, which after a load balancer is able to shard the data or share it or distribute it along these instances of VM storage, and VM select, which is if you want to look at your data and that is distributed, you need to have this ability to take it. So it's not that complex, really. If you compare it to other projects that I will mention briefly, it's not that complicated. So it helps for horizontal scaling, and also it provides data replication if this is something you need, and data isolation, meaning tenants. Normally, when people work at large enterprises, they need tenancy, and this comes with VictoriaMetrics cluster. And with this, you can go, if you didn't like this 100 million time series, then you can go up to billions. And we actually show these numbers when we go to KubeCon and these conferences. We always have a stand with real running cases, and people like to see that. Okay, so we have all these things we can do with VictoriaMetrics. But as I was saying, we are open source. There are many projects. There are, if you are looking into scaling your metrics solutions from Prometheus, there are others you can look, and don't really argue like, but you are not mentioning them. Like, they are all cool, really. For example, if you are very much into the Prometheus project and you love it, normally Thanos is a good step. It can be very complex as well. It's really up for taste. If you are really into the world of S3 storage, right, that may be Mimir your choice. However, it comes with a lot of drawbacks. In this case, it will eat a lot of memory, and this S3 storage can be not that fast for you. So again, trade-offs, as I was saying. But as Alexander was saying before, it's not only about putting more data. You just need to, there is a point which you need to take a look at what's going on. In this case, VictoriaMetrics offers these dashboards that help you and guide you to improve and monitor how your instances are doing. And it's also important to check, right, and read. And for this, for example, by the way, if you want to try these things, there are playgrounds on the internet. So it's playvictoriametrics.com, for example. And let me just show you. Where are you? I think this is you. So, okay. Here you can explore your cardinality, and you can check, because normally high cardinality means trouble, so you can check which metrics are the more high in cardinality, or for example, you could check from your queries, and it's weekend, so this project is not being used so much because this is a running instance, but in this case you can check, like, okay, this query is taking 2 seconds to be taken, right? This is a lot of time. What can you do with this kind of, when you have these problems? For example, what you can do is you can create recording rules. In this case, recording rules will be running every 15 seconds by default, and be generating these byproduct metrics that you can use and be super fast, because you don't need to be doing all these operations. They are recorded in one. Of course, this adds a bit more load into your system, but it's one thing you can do. It really depends. What else can you do with the Victoriaverse, right? There is this VM agent, and I don't want to bore you, so I promise this part in metrics is nearly finishing. But the VM agent is a thin one that can help you. For example, one thing I love, I wish I knew this one back then. We were having a customer that they were running in IoT, meaning that many small devices everywhere, and there were disconnections. So one thing VM agent can help you a lot is to buffer this data, and when they get connected, they send the data again. And you don't need to install a Prometheus. Sometimes use Prometheus as agent, but that will be super big compared with this, right? Relabeling and also streaming aggregation is a very cool feature that you can use to, for example, not having these granular metrics, like a lot of them per second. Just imagine, you can say, okay, every 5 minutes, you aggregate this into one metric and give it to me. So now I reduce my load. So it's really important to know your data and use these kind of things. What else can you do with VictoriaMetrics? Creating alerts. I guess here in the room there was some conversation about alerting. VictoriaMetrics provides VM alerts, so you can get notified in the Slack when, hey, your disk is running out of space, so take a look. Also, there is this small component VMAuth that will help for authorization, for example. Let's authorize this one, not this one. And the operator, if you know the operator pattern, is this thing that can talk to the Kubernetes API and do things for you. In this case, it's a helper to manage a complex. For example, if you're using a VictoriaMetrics cluster, it helps for these operations. And all of that is open source, and it's great. And this is the only, let's say, part that is not open source, but as support docs, we all need our treats and need to eat. So many companies, when scaling, they need support. So one thing that is not provided maybe in the Prometheus ecosystem is enterprise support. VictoriaMetrics have that option as well. And if you don't want to even run it in your own cluster, you can send it to VictoriaMetrics Cloud, which is the team I work in. So what? You may say, because we were discussing about metrics, right? But unfortunately, at the end of the day, we have this setup. When something fails, what will you do? You will make kubectl-logs this pod and check, okay, I didn't find the issue. Let's make kubectl-log in this other pod. Okay, I didn't find the issue, and so forth. And then you will do a cluster-wide log search, and then you will end up here again with a super huge pile of lines. So for that, to log at the scale, you need to do some adaptations. They are not that big, but you need to do some stuff. So how does it work? When you're in Kubernetes, normally, instead of just throwing things to the console, you just need to write them into a file and wait for someone to take them, process them, and write them. Luckily for us, in Linux, every thing is a file, so the console is actually a file. So you are already doing that. You just need to put an agent. The agent I like is the OpenTelemetry collector for various reasons. And you can put it to work for you in these two ways. You can push from your libraries, like directly with the OTLP protocol in HTTP or gRPC, or if you don't want to make this migration inside your code, this collector can help you and scrape those logs and take them out somewhere. This is just one example. There are many agents. FileBit, FluentBit, Vector that integrates very well with VictoriaMetrics. We are even writing our own because in this case we want some performance that we didn't find, and in this case there is one on the works, if I remember correctly. And this is more or less how it works in Kubernetes when you are scaling. And if you want to check what happens to your log, we were having this thing that said error, or hey, this is my log, or I was here, for the future when I was reading whatever prank you want to put. And this is how a log looks like in OpenTelemetry. So the point is, even if you're using OpenTelemetry or any other parser, if you are enriching data, you will be, like I was showing you that the logs were very hard to read. Now it's even worse. And I was actually under this situation while I was developing these backend projects that I was telling, because we needed to write these logs in this format, and when we couldn't even read them because we didn't have the tool, right? When we were testing and doing our own things. Normally, what people we were discussing in metrics, we were discussing about Prometheus. Normally, or back then, the standard was, or when you were to conference, everybody was talking about the ELK stack, right? The elastic stack. In this case, the proposal from ourselves is VictoriaLogs. There was this great talk just before me today. And someone was asking about this UI, and I can show you why this is important, right? I was showing you, like, I go kubectl this, kubectl that. It was a mess. So let's try this, and of course pray to the demo gods and hope this will work. Should be fine. So in this case, I have a client and a server just sending some requests, and when I get an answer, I will just will this work? It works. Okay. Let me last 5 minutes. Yeah, sorry for that. Okay, so, and I am throwing all these logs. Then, of course, spoiler alert, they are like this, right? And what I'm doing is I am aggregating them with an OpenTelemetry collector, and in this case, pushing them into a VictoriaLogs instance. So what I need to do in production, right? Like, hey, just imagine, hey, we are having a problem with, in this timestamp more or less, with delete operations. What would you do, right? So maybe you start saying, okay, if this is this timestamp, for example, just imagine I am focused. Let's go for the last 10 seconds. And then I just focusing on the last 10 seconds, right? And now I have all these other logs about this all other requests. So let's say, let's only focus on those who says delete. In this case, I have reduced my query for a small amount of these logs. And I can check them, and I can check all this information. I can check, for example, I don't know, did we have a restart in this container? And because I'm using, I am enriching my data with OpenTelemetry, in this case, you can do it in many ways. I know that this container had one restart. So it's giving me already some information, right? What else can I do? Just to give you, what I can check is, okay, how many happened of this, right? Like, how many deletes do I have? You remember we were talking about, so there is this cool count or mathematical operator that we can use, and it will tell us that, okay, in the last 10 seconds, you had 250 of these logs. So you don't need to go grepping. Like, we love it, we know it, but now you can do it here, and you can get all this information without creating the metrics, right? That's what I was saying. Like, yeah, it's cool. You need to create your own metrics, and you need to model them, all of that. In this case, we're just taking some random logs I was writing, and I was exploring my data and what happened really in production. So this is something. This kind of solutions, they help to do these things. You can also, well, in this case, I just had it in case this didn't work, but as you can see here, you can, if you are using Grafana, you can embed these queries together. So in this case, I'm showing everything that is going well, the kind of requests I'm sending, the latencies, and also the logs. So I can have everything centralized and check what's going on. So just if you allow me one advice, normally people love to have dashboards forever, and that's okay to monitor one thing. Like, I want to get notified if something happens. But if you want to investigate something, don't think that one dashboard will help you, like one old one. You will need to create one all the time. But this is just my own preference. About benchmarkings, like, is this thing good or not? We just learned from the previous talk that that VictoriaLogs is showing really good in benchmarks. In case this is public information, actually ClickHouse has this benchmarking there, which is so you can check it by yourselves or compare with other if you are evaluating databases. Of course, the use case is not going to be yours. So let me go back again to my advice earlier. If you are going to select or try to find the best case for you, use your own data, use your own use case, and check. In this case, if you compare with Elasticsearch, MongoDB, or Postgres, VictoriaLogs is just performing much faster and everything. Of course, what can I tell you, right? There are also benchmarks done with Loki. This is like super new. I was just taking these screenshots, and actually Alexander was sharing the same example earlier, but just people is reporting repeatedly that there are improvements when you move into this ecosystem. And yeah, if you want a bottom line for a log-heavy search-centric use case, VictoriaLogs lets answer questions in seconds instead of minutes. And this is important because if you are debugging something, like if you need to wait for minutes, then I don't know, you just want to quit your job and maybe, I don't know, go to a farm or something, which is actually my life goal, but we can talk about that. If you want to scale, again, VictoriaLogs single scales vertically very well, but there is also a cluster version. I will not repeat it again. It's more or less the same architecture because, of course, it's done by the same people. So you can imagine that. And this was what I had in general for like what I thought about this talk when I submitted the abstract some months ago. Now, in these months, things has happened. And let's play a game. So, because you would say, or I was arguing, Prometheus saved our day, which was good. Then Prometheus was not that good, and we needed to change to VictoriaMetrics. Okay, we need to scale VictoriaMetrics, then logs, how we scale with logs, all of that. But you know, before I actually left this work, I learned something. So let me explain what I learned. If I ask you, like, I'm going to show you 3 dogs, right? If I ask you, or if you were to think, like, what is this dog doing? Many of you may tell, like, okay, it's laying down, right? Or whatever. Pick your whatever you want. Just think about it. If I ask you, what is this dog doing? You would say, it's standing. It's not jumping, it's not running, it's standing, right? And if I ask you, what is this dog doing? Maybe it's a bit sad, you know? But I can tell you why it's sad. This dog is sad because you don't have context. And context is the important bit to understand what on earth is going on in your cluster. And for that, that in modern observability, it's called traces. It's not that modern, really. It's been here for a long time. It's just that we don't use it because it's a lot of effort, because we like to just say, error here in the logs, and then I throw it and somebody else will take it, you know. But, and by the way, if we are talking about scaling, one advice I would say is the guys that instrument your code are the ones that need to be maintaining your code in production. Those guys need to be the same guy. So the guy that gets called is the guy that writes the logs and writes the traces. But that's another conversation. But it's important for scaling. So what is tracing? Really, long story short. Sorry, just to ask, do you guys use traces in production? Anybody? Not that much. Okay, then I remember when I was doing this process of running into the microservice world and all of that I told you, I remember I was discussing with some colleagues, like, why don't we have a unique identifier for this request, right? I was telling you, like, hey, I have this incoming request that goes to microservice A, then that may go to C, then it can go to E, then it can go back, these kind of things. Why don't we have a unique identifier? I was working in telco, so we were complaining about the system engineers and the standards, like why they did not implement this thing, because we are not in a good shape when we are trying to debug. So we failed to write this, because then there were libraries that we needed to write our own libraries, and then there were like different languages and all of that, right? So distributed tracing is what brings this unique identifier into the table. It's what is telling us what happened before a request came to you. And that's what will help you, like when you are running thousands of requests per second, finding that one that is wrong and comparing to one that is right, traces is the one that will help you. And that's done with spans. So when your request starts, then it assigns a unique identifier that gets propagated. So two concepts. First concept, this unique identifier, and context propagation is the important bit. Okay, at the end of the day, you will be able to write something like this that I can show you, this great project that is called Jaeger, that works. That's cool. And here I'm telling you, hey, give me all the traces for the requests that has this service name and this operation, in this case, delete. And then it's trying to find them. And now I can, and here I can check all my requests, how much time they took. Sorry, in this, I didn't prepare an example with one failing that will be red and all of that, but you can imagine. Maybe if you give me that, please. And in this case, I have my code instrumented in this way, that I have a traffic generator and a service. And what I do is I send a request and it gets back. Then I send another request and it gets back. And I send different. So in this case, that's what I'm saying here. Of course, it's very small, but it says post. And here I have my get request, and I have my put request, and I have my delete request, and I have all of them grouped with the same ID all together. So in this case, I can debug what happened through the whole process. These are 5 requests all together between, you can imagine, between different microservices. But you can come here and check all this information. Like it's a post message, and it returned with a 200, and all this information with OpenTelemetry. And you know what? You also have logs in traces. So whether you believe it or not, many companies are adopting tracing first approach, in which they promote into their internal teams, use tracing, don't use just logs. And it's bringing a lot of great results. And I will tell you, great results until you need to scale. And this is something I really liked. I remember I was discussing about traces, and then when I realized that this was in the oven, I was very happy. VictoriaLogs started with many things in mind. One of them was wide events and also OpenTelemetry format. OpenTelemetry format started with traces, so you can imagine how easy it's been to. Oh, I see. Maybe Jikun, the main developer here, will tell me no. But it's been not that hard to try to make a distributed tracing backend out of VictoriaLogs. This is on the works. So VictoriaMetrics will provide soon this. There is a already documentation and a GitHub repository. If you like the VictoriaMetrics ecosystem and what I just showed you, you can also keep an eye on this one, because I guess it will be very cool very soon. So my last thing to tell is metrics helps us to understand or to be notified when there is an issue. Like, hey, you are running out of disk. then you get an alarm, they told you, and then you get inside. But to understand what's the issue, that is logs, what tells us, it's traces. So if I can tell you just one recommendation, if you are scaling, please use the tool for the right thing, because otherwise you're not maybe doing the great job. So thank you very much, and I can guarantee you no animals were hurt by doing this presentation. Thank you, guys.
Thank you very much for this talk. Are there any questions? Yes.
So we're currently using Sentry in our company. Do you have any experience with Sentry? And if so, can you talk a little bit about how you could replace it, integrate it into the whole tracing thing?
May I ask, Sentry, is it just cloud-based or is it open source? Like, do you run it on-prem or?
It has a cloud offering, but we host it ourselves.
You use open source, you mean? Okay. In this case, I would need to know more, of course, on how you use it, but I guess you are collecting, how are you producing your signals, if I may ask? Yeah, sorry, I'm making you.
Yeah, I'm not the developer, I'm the admin running the thing, but our teams integrate the Sentry libraries into the applications so they can push the stuff to our server.
Okay. I will not try to answer specifically your question about Sentry, but I can tell you a bit about the ecosystem. So what has happened a lot in the observability space is that there were these companies, I don't know, Datadog, Dynatrace, and I didn't know that Sentry had their own libraries and all, but they realized that doing this is very expensive and it takes a lot of time, and maintaining that is super hard. That's one part. The other part is that when you start using libraries from others, then you are locked in. So when you want to change, one thing is changing one component, but changing your whole code base, that can be a mess. And that's one of the reasons why OpenTelemetry started. Don't think that OpenTelemetry started as, you know, something super nice for everyone. That's true, but there is also a business justification, and that is saving costs for these big companies, and also, you know, like having this ecosystem. So maybe one good step if you want to get outlogged is to start moving into an OpenTelemetry libraries that they probably will give you all that information. I guess Sentry, if they are an observability player that they will be able to get that data. So with that first step, you will just be detached, like forever. Like maybe you like the project, and then you can start experimenting. Another thing I've seen is, as there is no one size fits all, even in the same teams, right? Like you can be using a cloud vendor and a small Prometheus I spin up for my tests, or a small VictoriaMetrics, they work together, or from a Prometheus I send things to a VictoriaMetrics. That happens. So I would just tell you that I would need to know more about the case. But these are strategies that may help.
Okay, thank you.
Thanks.
Thank you. One particular nice thing about Sentry, I'm using it as well, is that you can link to your code base, and if there are some error messages, you get your code shown where things blew up.
Wow.
Is that cool. Also possible in the Victoria environment somehow?
So, so far, VictoriaMetrics has been focused really on the database side of things. So to answer that question, I would need to understand how data is extracted and how it's formatted. And yeah, so we normally we try to integrate with everything we can. So actually, if there would be anything we could do to help, I guess the community will push for that.
Cool, thank you. Any further questions?
I have no question, but I have additional comment which I forgot presenting in my talk, and you forgot missed in your talk, is that we are at FrOSCon conference, and it is assumed that the majority of attendees here use Linux and use console, like working with console instead of working with some UI and web UI. And important point is that VictoriaLogs provides VLogs CLI tool. It's an interactive command line tool for querying VictoriaLogs, and it's similar to PSQL for Postgres. So that's just additional detail.
Yeah, thanks for bringing that up. Yeah, that's actually pretty cool. Like you don't need to go to a UI to start querying. You can just go into your own console, and these kind of tools really enrich the ecosystem. Yeah.
Okay, the nerd in me likes that. Any further questions? Otherwise, thank you again for that very informative talk about the, I guess, whole Victoria ecosystem and the outlook to the future.
Thank you very much. Thanks, folks.